Good morning, students. Today we discuss about parameters of progressive wave. Parameters of progressive wave. In previous class we discussed what is a wave and types of waves, and also in the type of waves differentiate, that is difference between longitudinal waves and transverse waves. Okay, and the main fundamental definitions are discussed in this topic, that is parameters of progressive wave. First of all, you see this is the vibrating particle. This vibrating particle will be vibrate its mean position. This is the mean position, then it will be vibrate up and down direction. Okay, due to this the wave will be generated. See this is considered as x-axis and this is considered as y-axis. Okay, on the x-axis we can take time. So in this situation, this is the object. Then the particle first is at O, then it moves upward direction, then the representation of wave is like this, and the particle will move at mean position, that is it will be reaches to mean position. Okay, and again the particle will move downward direction, then this is the representation of wave in the downward direction. Now finally the particle will move mean position, then complete one oscillation. This is the representation of the vibration of the particle in the form of waves. Okay, so see this, first of all the particle is at origin. Now the particle will move maximum displacement, then the particle will move mean position, again the particle will downward direction, that is maximum position in the downward direction, and next finally the particle reaches to mean position. Okay, so the particle to complete one oscillation, so from this one we define some parameters of progressive wave. One is amplitude. It is represented by capital A or small a. Okay, so what is the amplitude? Okay, the maximum displacement of the vibrating particle from its mean position is called amplitude. That is, the particle, this is the mean position of the particle, then it will be maximum displacement. This is the maximum displacement in upward direction, and this is the maximum displacement in negative direction. So this is the maximum displacement of the vibrating particle, then it is called amplitude. This is also called amplitude. And these units of amplitude in SI system is meter. Then what is amplitude? The maximum displacement of a vibrating particle from its mean position is called its amplitude. Okay, and next we discuss about phase. Very important point, phase. What is a phase? Phase nothing but pi, or it is represented by also theta. Okay, so this phase pi or theta, we consider some formula is this phase pi equal to kx plus or minus omega t. Ax plus or minus omega t, or this is also represented by theta. If the wave will start from origin, then x becomes 0, because wave starting from origin, that is 0. Okay, then this phase phi equal to x becomes 0, then it give only omega t. Phi equal to omega t, or theta equal to omega t. This formula you will be now in oscillation chapter, first year oscillation chapter, because in circular motion the particle is moved from origin to at a point P. So this is the radius of the particle, is nothing but amplitude, and the angle is theta equal to, you can write omega t, same as t. This is the phase. Then what is phase? And what is phase? Phase, it is an angle which gives position and direction of a vibrating particle. Position and direction of a vibrating particle. Mainly which gives position and direction of the vibrating particle. For suppose the particle is moved from origin and reaches to maximum displacement point, then what is its position from the mean position, and what is its direction or angle from the mean position? Okay, so this is discussed by using phase. This is second parameter, phase. Okay, so first of all, this is this side. You can take a circle also. Okay, and this is origin. Now phase is an angle. Then we have to represent the angle also for this wave. So this is 0. Then this one is pi by 2 angle, and this angle is pi, and this is 3 pi by 2 something. Okay, so then 0 to maximum point, 0 to maximum point, then this phase will be pi by 2. This phase will be pi by 2. Okay, so this phase will be pi by 2 at this point, and this point pi by 2 to pi, and this point 3 pi by 2, and this point finally 2 pi, and again next. Okay, it will be continued. So for example, we can take a wave is starting from origin. We can take some points on the wave. These are the point A, B, C, D, E, F, G, H. You consider some points. Okay, so in these points A and E, we have to say are in same phase. What do you say? Same phase, because they have having same maximum amplitude points. Same maximum amplitude points. For example, the O and D, that is O, and this one D, which are also in same phase, because of it's moved from origin. Similarly, this is also starting point. We consider starting point. So we have to say 0 and D are in same phase, and also A and E also in same phase. Similarly, C and G are also in same phase, and next D and H are also in same phase. So same phase points can write 0 comma D, A comma E, and C comma G, and D comma H. And remaining any 2 points we compare, they are in out of phase. They are in out of phase. Okay. In case O and A, O and B and G, all are in out of phase. Okay. So this is the phase. And what is the phase difference? What is the phase difference? Okay. Phase difference. What is the phase difference? You know that in first year dx, displacement dx, we can write x2 minus x1. Then in this also phase difference d pi equal to, we have to write pi 2 minus pi 1. That is, we consider two waves on 2 points. Then what is the difference between these two waves? Okay. So once again say that what is phase? Which is an angle which gives position and direction of a vibrating particle. First of all, the particle is moved from 0 to maximum position. Then what is its phase at this point? This phase at this point is pi by 2. In case the particle will move downward direction, then what is its phase? Its phase becomes 3 pi by 2. Okay? And what is phase difference? We consider two waves. One wave starting from origin and another wave is starting from maximum displacement position. Maximum displacement position. That is, first one phase is pi 1 equal to, is starting from 0. Then second wave is starting from phase pi by 2, that is pi 2 equal to pi by 2. Then what is the phase difference? Then phase difference delta pi or d pi is equal to pi 2 minus pi 1. Then d pi equal to pi 2 pi by 2 minus pi 1 is becomes 0. Then d pi equal to pi by 2. This is the phase difference between these two waves. General example. One person will move 2 km per second and another person will move 5 km per second. What is the velocity difference? Then 5 minus 2 is 3 km per second. Okay, 3 meter per second. Same as it is in this also. Then which wave? What is the difference? Phase difference between these two waves is equal to phase delta pi or d pi pi by 2 and phase angle, then we can write in units radians. Okay, so in this we discuss amplitude and phase. Next we discuss another parameter.